water reduction. A reduction in chemical is when a substance accepts electrons. So in the cathode side, in the cathode side, the reaction is a bit complicated. It's a reduction of the air, of the oxygen of the air. The oxygen goes into the cathode side and react with the electrons that come from the external electrical circuit, and reacts also with the protons that has passed through the membrane and produce water. Oxygen, electrons, and protons produce water. So this is the basic physical and chemical function of a fuel cell stack that, as you can see, produce only electrical power and water.
You said that one cell only generated 1 volt?
Yes, 1 volt.
So if you need 800 volt, you have to put 800 cells away?
Normally the biggest fuel cell stack that I know has 400 cells, and you produce 400 volts only. But the DC-DC converter transform this low yes, correct. The low voltage from the stack is converted to the high voltage of the continuous circuit.
But these cells are connected in serial.
Yes, that is why.
If one cell is broken.
Yes.
Nothing works.
Stack is over. Yes. If only one cell is, for example, the membrane is broken, the voltage of the cell is down to 0, and the whole stack doesn't work, because in series connected, you know that the voltage is the adding of every cell, but the current is the same in all the cells. If only one cell doesn't work, this cell cannot transmit the current.
And this current that the cells generate goes to charge the normal battery of high voltage?
Yes. There are several configurations. For example, Toyota in Toyota, which is the Toyota name that works with the fuel cell. Has very small battery, only I think 1.5 kilowatts hour of energy, which is a very, very small battery. And this battery only makes the function of start the system and the supply acceleration of the engine for 10 or 20 seconds only. In other systems, which are more hybridized between the fuel cell system and the battery has a higher capacity, maybe 60 or even 80 kilowatts hour, and the supply of power to the electrical engine is more complicated. Sometimes it's the fuel cell directly, sometimes it's the battery. It's an hybridization, and this is the configuration normally in the heavy-duty transport. They have also high capacity batteries. Yes.
In cathode side, in the main supply, there's only oxygen gas, or
No, this is a simply representation. Obviously, here you supply air, which is 78% of nitrogen, 21% of oxygen, and 1% of argon, and the other gases, argon, nitrogen, do not react with only oxygen reacts. Yes, but you are right. You supply air normally. Not always. There are some special applications we will see later in which we supply oxygen only. For example, my company is working for the Spanish Army that has a submarine that has a fuel cell system in order to make a propulsion underwater when there is no air, and the submarine has a tank with oxygen. And then in this case, in a submarine case, you supply only oxygen, but it's a very special application, and it is not normal in trucks, in trains, in airplanes, in every normal application. You supply air. Okay. Okay. This is the same schematic representation of a fuel cell, of a cell, but this is with real components that we manufacture in our company, in AJUSA. And the real components of a cell is a bipolar plate, a MEA or membrane electrode assembly, and a gasket. These three components are the main components of a real cell in a fuel cell stack. The bipolar plate, the function, you can see here a lot of small channels that transport the hydrogen in one side or the air in the other side through all the active area of the MEA. This black component is the MEA, which is the membrane with catalytic electrode anode in one side and catalytic electrode cathode in the other side. And this MEA is in which the electrochemical reaction happens. But the bipolar plate supply the air and the hydrogen to all the active area of the MEA. And also the third component, which is very important also, is the gasket that separate the three circuits, air, cooling, and hydrogen, and not but it is necessary to separate and not to mix. And the gasket has a very important function. And this cell is repeated 400 times. Bipolar plate, MEA, gasket. Bipolar plate, MEA, gasket. Bipolar plate, MEA, gasket. 400 times. So in the external part of this stack, there are current collectors in this these parts, we have, for example, 400 volts and 500 or 600 amperes. And in these connectors, you can supply the electrical power to an engine or whatever you want.
How's the really size of the cell like this?
For example, 100 kilowatts stack, which is a usual power to a stack. The size of the cell, the length is around 450 millimeters, something like that. The height is only 200 millimeters, something like that. And the length is 500 millimeters, more or less. This is more or less the size of a 100 power stack. Some question? You can see here some of the components that we manufacture in AJUSA. This is a bipolar plate. We manufacture this component by stamping a special stainless steel. And you can see here the three manifolds, really six manifolds: intake air, exhaust air, intake hydrogen, exhaust hydrogen, intake cooling, exhaust cooling. These are the six manifolds that you have in a fuel cell stack, and the channels that distribute the reaction fluids and the cooling fluids in all the active area. And this is a MEA with a gasket integrated. Here the electrochemical reaction takes place and generates normally only 1 volt and a lot of current. It is possible to generate 500 or 600 amperes in each cell. And the gasket, we produce the gasket with a special liquid injection of silicone. Because the gaskets are very, very small, very thin, and it is injected in liquid phase and inside a mold reticulate to a elastomer material, which produce the gaskets. And this is a real stack that we produce in AJUSA. This stack is around 25 kilowatts power. All of these small cables, ¿cómo se dice en inglés? Cables, is because each one of the cell in a stack, it is necessary to control the voltage of each one. This information goes to the fuel cell control unit, and if only one cell doesn't produce the correct voltage, the fuel cell control unit stops the system.
And you can repair it?
Yes.
And you know which one is the...
Yes, of course. Every cable has a number, and the fuel cell control system receives this information. And if a cell is broken, the voltage number 200, the cell is broken, the fuel cell control unit stores the number of the cell that the volts is becoming 0. So the stack, it is possible to open, change this cell, and close again. It is possible to repair the stack. Yes. Some question?
Is it very heavy?
Around 1 kilo per kilowatt. So 20.
100 kilos.
Yes, more or less. 100 kilowatts stack. The weight is 100 kilos, more or less. But the whole system